Hi, welcome to this overview video of class design in C++. So let's get started. So first we want to review structures. So structures are objects without, you can put diverse data into one struct, but you don't add member functions. You just have a bunch of different data, a collection of different types of data, and they are all inside the struct in a little, with an opening curly brace and a closing curly brace and a semicolon here at the end. And you can, but the difference between a struct and a class is that with the structs, you don't add functions. You just create a collection of different types of data and then treat that as one single item. And then you can declare objects. So if we have this new CDA account, then you could have CDA account, account 1, CDA account, account 2, etc. So this is the placement in your program. You have up here at the top of your program, globally is where you define the struct. And then this is your function prototypes up here. This is your main function. And you can see we have declared two objects of type CDA account. And then down below here is where you put your function definitions. So this, you would define the structure up here globally, so it can be available to everything. And then to make code easy to read and understand, you separate the function prototypes from the function definition, place function prototypes above and function definitions below. So this is a review of structs. So now we're just going to go over some definition. So what is a class? A class is a data type whose variables are objects. So you define classes the same way you define structs, but you can you also add member functions so you can perform operations on these objects. So a struct, you create objects, but you don't have any member functions. There's also some other differences which we'll get into shortly. So an object is a special kind of variable that has its own special purpose functions. So technically when you define structures, you don't really make objects, you make instances of your new data type, but you know, C++, so structs are still used a lot because maybe you just want to have a bunch of different data that's treated as one item and you want everything to be public, so you would use a struct for that. And then a class is where you're going to add member functions and design abstract data types and designate differences between private and public. And a stream is a flow of data. And in the last module, we went over file streams, IF stream and OF stream. And those are also objects. When you declare an object of type IF stream or OF stream, then you use the dot operator to access the member functions of that. You also have been using IO stream, CIN and COUT, and you can use the dot operator to access member functions as well. So let's talk about classes. All right, so a class, you have you create objects. The object is the actual value of the variable. So when you create a class, you declare objects of that new type. And an object holds different types of data. So it's the same as a struct. You can keep, you know, you can create it with a bunch of different data, but it has a lot more features. So now we're going to get into the concept of public versus private. So by default, all member variables in a struct are public. So you don't even have to put the keyword public. It's going to automatically, when you define a structure, everything is public. That means it can be accessed outside of your struct just by using the dot operator. In a class, all member variables are private, but when you create your class, you can decide what you want to be private and what you want to be public. So you use these keywords private and public, and there's also protected to indicate what you want to be private and what is public. So private members are only accessible inside the class, and public members are accessible outside the class using the dot operator. So we're going to get into accessor and mutator functions or setter and getter functions in a moment. Okay, so here are some of the features of using classes. You have encapsulation, so that is bundling data into a single unit and using methods which are member functions that operate on that data. So you want to hide private data and use public accessors to, and you specify, when you create your class, you specify how things can be accessed. Abstraction means that you only want to expose the essential details. Inheritance we will get into later in the semester, but you can reuse properties of like having a parent class and a child class so that you don't have to reinvent the wheel for things that could be used by and inherited from a parent to a child. We will be doing that later on in the semester. And polymorphism is the ability of a single variable or function to handle different types of data or objects. So we have different types. You can do this through function overloading, and you can do it through overriding, and you also templates are also a type of polymorphism. We will go into much more detail on polymorphism with inheritance and the concept with overloading functions and also with templates later in the semester. All right, so here's an example of a class member function and the scope resolution operator. So you might have noticed if you just log on to any compiler, it uses this. If you don't put using namespace standard, in order to use cin and cout, you have to use the scope resolution operator. So you've already seen the scope resolution operator, I'm sure, when you log on to your compilers. This right here is not actually a function. This is saying we have the return type. This is the name of the class, the name of the function, and the formal parameter list. So this is just overview. So this is an example of an actual, the return type of this would be void. The name of the class is day of year. You use the scope resolution operator here, and the name of the function is output. So this is not the function definition, because the function definition is going to have a block of code where you actually define the statements that implement the function. So this is just notes and overview. All right, so member functions, when you write the member functions, if you define the function outside of the class declaration, which is the way we're going to do it in this class, you're going to separate your class declaration, which is like the prototypes, the member variables, the member functions. You're going to separate, that's the declaration, from the implementation. So when you do the implementation, you're going to have to include the scope resolution operator for your function definitions. So you're going to have a lot of examples, and there's an example of the vegetable class right here in the module, so be sure to take a look at that in detail to understand how it should be set up, separating the declaration from the implementation. All right, so that's what I just said. So we have the declaration, which is actually would be the .h or .hpp or .h file. So that's like what's called the header file. So the declaration, you would put the declaration inside of what's called the header file, and then the implementation would be in a .cpp file. So you have already seen the difference of, we just separated our function prototypes from our function definitions. And with classes, you have the declaration, which would be in one file, separated from the implementation, and you would use the scope resolution operator for each function definition and include the name of the class. Right away, first we're going to just separate the declaration and the implementation in one single file that also has the main, but later in the semester we will separate our implementation. But for this, for the next few assignments, particularly the next assignment, we will not separate we will separate the declaration, but it won't be in its own file. We'll have the declaration followed by the implementation, which I will show you examples. All right, so this is an example of a declaration. So this would go at the top of your program. And the difference between this and a struct, you can clearly see. First of all, we have the keyword class instead of struct. You still have an opening curly brace and a closing curly brace and a semicolon. And here we are defining what is private in our class and what is public in our class. Even though by default the everything is private, it's very clear if you, in your declaration, you designate what is private and what is public. And very good class design is to make your member variables private, and so they're only so you can't declare like day of year D1, say, and then go D1 dot month. You cannot do that outside of the class because it's private. So we're going to talk about how do you get this private data. You use what's called accessor and mutator functions. So there's things you want to include in your classes. Every class should have a constructor. This class actually has two constructors. It has the default constructor. So, and again, this is not the implementation, this is the declaration. This is like the prototype. So if you've been using function prototypes, you can see these are function prototypes. These are the member functions for my class. And this is the data that's in my class. And this data is private. So the only way to access this data is through my member functions. So when I declare an object of type day of year, again, if I'm in my main function or any other function and I declare day of year D1, that's going to call the default constructor. So whatever my default day of year is, D1 is going to do that. Now we also have what's called an explicit value constructor, and because both of these two functions have the same name but different parameters, they are called overloading the function. So if you have two functions with the same name but different parameters, that's called overloading. So the default constructor, if you declare an object of type day of year, it will call the default constructor automatically, but you can have an object of type day of year and pass it to integers so that you can actually define what, so you could have day of year D1 would call the default constructor, and then you could have D2 and pass it 12, 25, and this would call this one the D1 one, this one would call the default constructor, and it would be set to whatever day. I'm not sure that month and day are in the right order, but obviously comments would need to be here to explain, to put it in the right order. But I'm assuming that it would be month followed by day. And this one would call the explicit value constructor because I passed it two things. So D2 would have the date of 12/25 and D1 would have whatever date has been implemented by the default constructor. Again, we don't have the implementation in front of us, but by looking at this declaration, we can, and if there were good comments, we would know how to declare objects of type day of the year. All right, so this is how you would implement the member functions. These are two of the member functions, which are called the constructors. So these would just be implemented. Actually, if you were separate compilation, this right here would be in your .h file, and these would be in your .cpp file. But we're going to do inline in one file for now. So you would just put this at the top of your program, and then right below it, you would put your implementation. And then below that, you would put your programmer defined prototypes, then your main, then your programmer definitions. Don't worry, I have examples, lots of examples on Canvas for you to take a look at and to, I'm just explaining, this is just overview and explaining the way we're going to be doing things in this class. So again, this would be the top of my program where I have my header comment. This is globally defined, the declaration. This is the declaration of my class. And then this class has 4 member functions. So these are the first 2 member functions. The first 2 member functions are constructors. This constructor right here is going to set the day, the month and the day to 0, 0. You don't have to do that. That would by default set the whatever day to 0, 0, which there really is no 0, 0. So it would be more fun to, put like a 1 here and a 1 here. So at least it would set, if you put a 1 in here and a 1 in here, it would at least set that to January 1st because there is no month 0. So this isn't a very practical default constructor. You can make your default constructor however you decide if you're creating the class. And here, this is the explicit value constructor where whatever number comes in here, so like we did 12, so this would be a 12, and then that would get assigned to the month, so the month would be 12, and we did 25 came in here, so this would be a 25, and that would be assigned to the day. So if you did do day of year by passing 2 values to it through the explicit value constructor, it's going to make whatever values you pass to it for the month and the day. So here's another class member function. See the scope resolution operator, the name of the class, and this is an input function. So this function, again, this does not need to have a dot operator because you're going directly to the month and the day because this is a class member function, and so the class member functions have access to all of the variables that are part of the class. And this is the output. So again, the dot operator is not needed, and this is just the implementation of some member functions. We have 4 member functions: a default constructor, an explicit value constructor, an input function that allows the user to input the days, the day and the month and the day, and an output to output the month and the day. All right, so the way that you could use this, the main function, obviously we need to have a main function. So the main function, we're going to declare 2 objects of type day of year. We have today and we have birthday. You can use the dot operator not to access the month and the day directly, but to access the public member functions, which then have access to the month and the day. So we use the input function. We use the dot operator to say today dot input, birthday dot input. Today is one object of type day of year. Birthday is another object of type day of year. And then you use the dot operator also to access the member function output. You can use this const here. This const just means that you don't want to modify anything inside the function. So that is also something that is used to make sure that the function doesn't modify any of the contents of when it's going to output it onto the screen. It's just going to keep the values. So birthday is holding a month and a day, and today is holding a month and a day. All right, private and public members. With an ideal class, you should be able to change the details of how your class is implemented, and the only things you need to change are those that use the definitions of the member function. So the idea is that you have control of your class, but you only want to change things. You only have to change it in your class. So you want to create what's called like an abstract data type, which means that you put in the definition of the class and how to use the class and the declaration and everything. And then if things need to be changed, any outside program, main function, or other function that's using objects of your class should not have to care about things that are changed. And that's the idea of it. The idea is that you should think of all different kinds of things that you can do and make your data private so that you are in control, so that you can't allow outside, you can manipulate it yourself. So you only want to access your member variables through your member functions. Sometimes you can use what's called friend functions, and we will see that later in the semester. So, but if you make all of your data private, then your member functions are going to be the only way that you can access this And what you use is you use what's called mutator or setter functions to change the values, and accessor or getter functions to get the values. So you don't want to have anything outside of your class access your private member variables. So you make them private, and then for each private member variable that you have in your class, you create accessor and mutator functions so that your class has the control of the private data. So here is an example. This is an example. We're just continuing with day of the year. We have two private member variables, month and day. So we have this is an accessor function. These two are accessor functions. So what does that mean? Also, they could be called getter functions. Okay, so that means that if an object like birthday, like you did day of year birthday, wants to access the values of the month and the day, you have to use these public functions to get them. So you're keeping your data private. Your two data variables are kept private, and you can only access those values by calling the accessor or getter functions. And this example has one mutator function. You could separate this into two mutator functions. You could have set month and set day, or because month and day are related as one date, you have one mutator or setter function. And it's very common for the function names to be like get month, get day, set month, set day, or set date, or set. So it's very common to use these names of your functions for accessors. They would be get functions. For mutators, they would be set functions. So here's an example. If you wanted to, again, the idea of this is when you design a class, you come up with all different kinds of options on how to create and manipulate and do things with objects that are in your class. So you could do day of year Christmas, and when you declared Christmas, you could, instead of using the set function, you could have declared Christmas and put a 12 and a 25 and called the explicit value constructor. So there's all different, the idea is that you have this declaration and you come up with different ideas on how to create objects of your class and how to manipulate objects of your class and how to, usually there's always, you're going to come up with more ideas because that's kind of what happens in programming. Like you have an idea and you implement that, and then you come up with possibly more ideas. In this case, you can have your default constructor, which is going to make, when you declare these two, both of these dates, Christmas and today, have a date of 00, which is kind of a useless date. So then you use the input function to set up that the input function, if you remember, it asks the user to enter the month and the day. And then we also could do it with the set function. And the set function, you call this set function with the dot operator. You've already declared the object of type day of the year called Christmas. Use the dot operator to set that date, and it takes two parameters, two integers. And then these are getter functions or accessor functions where you're going to compare the months to see if they are matching or not. So today.getMonth is going to return whatever month, and Christmas.getMonth is going to return a 12. So you're just using a comparison, an if condition with an expression to compare these two to see if they are at the same month. So once you make a member variable private, the only way you can change the value of that is through your own member functions. So That's the whole idea of encapsulation, is that you want to hide the internal workings of how your class is implemented and just provide the option to use and create objects of your class, and with good comments and a good declaration, explain how to utilize the features of the class. So the tip is to make all your member variables private. And again, I'm just reviewing here. You write an accessor or getter for each private member variable and a mutator or setter function for each private member variable. So this is just showing you again. In this case, we don't have a setter function for each variable. We just have one set function. But if I was designing this class, I might have a set, and then I might also add for this set month and a set day function. You can have, you know, as many functions as you want for as many different features that you might want to possibly use in objects in your class. So structs versus classes. This is review, hopefully. All members of a struct are public. All members of a class are private. So in a struct, you just define your data in your struct, and you can access it from the main function or any programmer-defined function. You can access the member variables by using the dot operator. In classes, you designate what is private and what is public, and a very good design is to make everything in your class, all of your data in your class private, and use accessor and mutator functions and member functions to manipulate the data. So generally structures, you can put member functions in structures, but that's not the design. That's not what they're meant for. They're just meant for creating a bunch of diverse data as one object, where classes are meant to create diverse data and not only have one object, but allow you to perform operations on your objects. A constructor has the same name as the class, and that is what happens when you declare an object of the class. The default constructor gets called. All classes should have a default constructor. As we saw in our other example, you can also have an explicit value constructor. Okay, I already said all that. All right, so here again is just reviewing the constructor. So this class happens to have two constructors. It has the default constructor and the explicit value constructor. We are separating the declaration here from the implementation, so you need to use the scope resolution operator. The constructor is the same name as the class. There's two ways to construct objects of class day of year. One is the default, which has a silly date of 00, and the other is to pass the month and the day. All right, there are also destructors. So destructors are used to clean up and to when everything goes out of scope. What that means is when your class is no longer being used, your class should include a destructor as well. In our first assignments, we're not going to be putting destructors. We will be adding the destructors when we get to dynamic memory allocation. So, I mean, you can put it in there. It doesn't really matter, but we're going to go into more detail when we get to dynamic memory allocation. All right, so the different specifiers, you can use private and public. We've already talked about private and we've talked about public. Protected can also be used, especially for inheritance. It's not used very often. It's usually better to make things public and use accessor and mutator functions rather than using protected, but it does exist. We will get into inheritance later in the semester. You have your base class, and then you have your derived class, and I left this here. If you don't use using namespace standard, you have to put, anytime you use cout or cin or anything that has a that's from the standard namespace, you need to use the scope resolution operator. So you might have already seen the scope resolution operator, We will be doing inheritance later in this class, so this is just an overview of the idea that you can have a base class, and then this is the syntax of how you put your derived class that derives from your base class. So the derived class can use the show and the display. All right, an abstract data type. So this is what I was saying. An abstract data type is what you want to use C++ to create your classes as what's called an abstract data type. And it's a collection of values. So you have all your member variables and you have a bunch of basic operations that you can define on those values. So we're going to start, small, but you can create vary classes and your new data type and how to operate, and you can overload operators, different operators, which we will get into later in the semester on how to add two objects of your class together or assign one object of your class to another one, or the freedom to do whatever it is that you are interested to do for your class, and you can create a bunch of member functions and how to operate on the data that's in your class. But the idea is we're going to start right now just by defining a class, making our member variables private, add our accessors and getter functions, or setter and getter functions, accessor, mutator, same thing. So an accessor is a getter function, a mutator is a setter function. It makes sense. You're going to set something, mutate it, change it. You want to access something, you're going to get the values. So we're just getting set up now on how to design our classes. And we want to design them with this concept in mind that you make your member variables private, that when you change your implementation does not change how anyone else can use it. So if you do have updates you want to make internally in your class, if you design it the right way, you don't have to any other program that's already used in your class. Like we're going to use the vector class, which has already been implemented. We're going to use the and that's actually a template class, but we're also going to use the string class, which is already implemented. We're use the ifstream class, the ofstream class we will be using. So we're using these, and we're using the dot operator to access member functions. And if changes were needed to be made to this, those changes could be made, but we would still be just accessing it the same way that we were before. And that's the whole idea of an abstract data type, is it doesn't require changing any program that uses the abstract data type. So how do you do that? You make your member variables private. You use accessor and mutator functions. You add features through the different techniques that can be used in the C++ language. And the idea also is to break a larger program into smaller tasks. So this is what I just said, how to define a class so that it is an abstract data type. You separate the specification of how it's used from the details and the implementation. So we're going to start by separating our declaration from our implementation. You make your member variables private and add accessor and mutator functions. Only make basic operations through public member functions. Specify, give good comments, and explain how to use each public member function. If you have any helper functions those that don't need to be accessed outside of your class, those should be private member functions. And then we've already talked about the const parameter, so you can include the const parameter, especially when you are using accessor functions, because the accessor function is not going to be making any changes or modifications to the data. It's just accessing and giving you those values. So we've started use the const. Const stands for constant. Keep it constant and don't make any changes. All right, so this module you will be implementing a class, so we will have an assignment, but it's important to understand these concepts, and there's going to be some, we want to separate our declaration from our implementation, practice using the scope resolution operator, practice having constructors, an explicit value constructor, a default constructor, and all of these techniques, and we will be adding on. So it's important to understand these techniques, one at a time. Don't try to do too much, and look at the sample code that is in the module. It will be very helpful. Thank you.